How does a dot diagram describe the motion of an object, and how can you use a dot diagram to determine the direction of the velocity and the acceleration vectors? Well, I'm Mr. H, and I have some answers for you. These are dot diagrams. They use a dot to represent the object position at constant intervals of time. For instance, these dots might represent the object's position for every 1 second of time. By inspecting the spacing between adjacent dots, you can determine if it is a constant speed, a speeding up, or a slowing down motion. In this dot diagram, the dots are spaced in equal distance apart. This indicates a constant speed motion. For an increasing speed, the distance between adjacent dots increases over the course of time, like this. And for decreasing speed, the dot spacing decreases over the course of time. They become closer and closer together. What if an object's at rest? Well, then you observe one big pile of dots located at the resting position. Some beginning physics students misinterpret the dot diagrams for leftward moving objects. When an object moves from right to left, the first dot shows on the right side of the diagram, the last dot on the left side, and you read the diagram from right to left. Vector quantities like velocity and acceleration have a direction associated with them. You can use a dot diagram to determine the direction of velocity and acceleration. But first you need some rules. The rule for velocity is simple. The direction of the velocity vector is in the same direction that the object is moving. So a falling object would have a downward velocity. An upward rising object would have an upward velocity. Acceleration directions are not so simple. That's because the direction of acceleration depends on which way the object is moving and whether it's speeding up or slowing down. Here's the simplest way to put it. If an object is slowing down, the direction of the acceleration is the opposite direction as the object is moving. Since this upward moving object is slowing down, its acceleration direction is downwards, opposite the direction that it's moving. Of course, you need a different rule if an object's speeding up. It goes like this. Speeding up objects have an acceleration direction that is in the same direction that the object is moving. So this falling object is speeding up. Its acceleration is downwards, the same direction that the object moves. In the description section of this video, you will find some links to some pretty awesome interactive exercises on our website. The best way to learn a new physics concept is to put it to practice, so you ought to try a few. I'm Mr. H. Thanks for listening.